we're going to at least start it. All right, we're looking at proving statements about segments. Okay? A true statement of other true statements is called a theorem. A two-column proof we've done, which talks about reflexive, symmetric, and transitive. Those are all properties you should be writing down your theorem and postulate. And we're going to talk about properties of angle congruence theorem. Segment congruence is reflexive, symmetric, and transitive. Okay, so we're going to start with this fun and exciting proof. Okay. We've got statements and we've got reasons. Okay. So we're starting with, yours is halfway filled out for you. It's got the statements, you've got to fill in the reasons. I know AB is congruent to CD. What do we call that? The given. Okay? All right. For number 2, I have AB equals CD. I've taken away the congruency sign, and I've taken away the segment signs. We call that definition of congruence.
What's that?
That's something that you should definitely write down. Definition of congruence means you can take away, you can make it equal. We're changing it from the geometry way to the math way. Okay? Now, if I say CD equals AB, what did I do to these? I just switched it. And which one? Reflexive, symmetric. 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 See, look at symmetric at the top. Do you see how it's AB is congruent to CD, then CD is congruent to AB? Yes. Do you see how reflexive is different? They're both the same? Okay. That's important. Everybody gets those mixed up. Now I'm going to say CD is congruent to AB. Now, look what I've changed. I've added that congruency symbol. I've added those 2 lines on the top. What are we going to call that? Definition of congruence. Whenever you're adding the little squiggle or taking it away on top of the equal sign to make it from congruence to equal or equal to congruence, we call that definition of congruence. You're going to use it a ton.
How come it's not on the sheet?
It's something I believe the book expects you to have learned in like algebra, but I don't know when you would do that.
I think
I tried to find them and I couldn't find any properties in there.
But write down definition of congruence because we'll use it a lot. All right, let's look at example 2. Let's look at example 2. Okay. Example 2, we've got, for our statement, under our statements, we've got RS equals XY and ST equals WX. What do we call that? Given. Good. And then this says that RS plus ST equals WX plus XY. What do we call that? RS plus ST equals WX plus XY. Angle addition, yeah?
angle.
And you mean segment?
Segment addition. Yes, I do. Okay, and now yours unfortunately was cut off and it's continued on the back. Sorry about that.
That's okay.
Okay, next we've got RT equals RS plus ST. This is also segment addition. And then we've got WY equals WX plus XY. Again, segment addition. So therefore, RT must equal WY. What would we call that? If these equal each other, then if we make these equal to each other, we call that substitution.
For 3 and 4, why would we call it substitution?
Because because you're taking, see how these are equal to each other, these parts right here? And these are, we're saying these are equal to each other because we took this out and we substituted this in. We took this out and we substituted that in. Substitution. Yes?
Shouldn't 3 and 4 be transitive?
No. They're definitely segmented. Okay. For example 3, it should be pretty straightforward algebra. Like if you can look at the picture, it will make sense. So we're looking at this, and I'm telling you that A to C is 91. And you want to find x. So you're going to go x minus 10 plus 4x plus 1 equals 91. And what is that called when we're doing it? Segment addition? We're not doing a traditional proof here. We're just saying how we would do it. Now we would go x plus 4x gives us 5x, and negative 10 plus 1 gives us negative 9. And I would call that combined like terms. Then I'd add 9 to both sides, and I get 5x equals 100. I call that adding. Divide by 5, I get x equals 20. I call it division. Yes, Abby?
How do you know it's segment addition?
Okay. If you got a segment, and it tells you something about this, and when we add them together, we get AC.
No, I mean the one before as well.
Do you see that RS, do you see the picture?
Okay.
RS plus ST would give you RT?
You just know that's it.
Yeah. So if it gives you a segment and it gives you parts of the segment or something, you know that you have to add them together. Okay? And I'm going to leave B empty for right now. Yes.
Can you go down again?
Yes.